Veo que habéis sobrevivido la mayoría, lo cual es...
Good morning, everybody. I see that you've survived, which is wonderful. We know that you've worked hard. My entry is going to be very, very brief because we want to give you the floor directly for the presentations. Just some housekeeping. You know what teams there are. We've made it to Sunday. We're going to be here from 10 to 12. From 10 to 12 we'll be in this room. Then we will move over to the hackathon area so that you do the voting. We will also submit you an assessment form, and around 1 we will have the scores. The closing ceremony will take place at 2. That's when the awards will be giving. I'd like to congratulate you all for your hard work, for your companionship, for your teamwork. You have 10 minutes per team. We have a timer so that you don't lose track of time. If there are any questions from the jury, well, we will raise your hand and take the floor. Remember, you have repository needs to be ready. I'd like to insist once again that it's very important that you convey clear messages, that you also tell us about changes if there have been changes as opposed to your initial approach. Make sure you highlight that during your presentation. It's very important that the remaining teams are aware of those changes. We as members of the jury already know. And when we finish, we will move over to the hackathon area. We'll provide you with a questionnaire. Let's talk about voting system. Each team will vote to the best 3 teams. So 3 points will be given to the team you liked most, 2 teams to the one you like second most, and then 1 point to the team that you believe should rank third. And then at 12:30 you will have already voted, so from 10 to noon we'll be here. From noon to 12:15 you will be voting, and then you will have some free time, and the award ceremony will take place at 2. As for the order of presentations, this is very important. You need to bear this in mind because you need to be ready. Santi will take the floor first, then we have Alejandro with PCA Creep, and then Monster Hack. Remember the scores of milestone 2. As you can see, it's very tight. It's very, very tight. Now is a crucial time. This is the acid test. Don't get nervous because we're here to learn from each other. We're also learning from you. I hope you learn from us, members of the year as well, and let the force be with you. Best of luck.
Hola, buenos días a todos.
Good morning, everybody. As you know, my name is Santiago. I'm a member of Mask team, the team that has been working on a malware web scanner. And first of all, I'd like to share with you the contents of my presentation. The first part is basically a copy of what I explained on day one regarding my objectives. Second, I'll explain my proposals for this hackathon and the proposals of the members of the jury. Thirdly, I'll explain to you what I've done in the end based on what I said and what you said. Then I'll show you a demo. I've brought a screenshot and I'll also do a demo with my computer. And then I'll talk about some ideas for the futures, about things I'd like to try out in the future based on my own ideas and ideas from members of the audience. Initially, Mask was going to be a malware scanner that could search and or clean, and if it could only search, the idea would be to be able to detect files with infected code in order to detect that file and report that to the user so that he or she could manually eliminate it. And the idea was that ideally the software would automatically eliminate those files and clean them, and also identify potential malware. I wanted to give it with the behavior of some well-known software that exists in this field. It's true that some scanners are not able to detect viruses. I wanted to work based on different scenarios, signatures, etc. And I wanted my solution to be scalable, meaning that if someone was willing to add a functionality, he could program an additional part and add it to my software. I wanted it to be able to be compatible with different content administrators. I'll explain a bit later what I've managed to do. I wanted to have a scalable architecture. I also talked about the need of protecting the site, asking for authorizations, also offer the user the possibility of restoring the website, i.e. restoring once clean and the website and leave it as it was originally, because maybe the cleaning isn't appropriate or it's excessive. And I wanted to use the signature, so there was the malware program that I found before coming here that I thought would be interesting also for my tool. On day one, the members of the jury suggested that I would register everything in the log, give the user the possibility of cleaning and adding a protection layer, because it's true that it's interesting to know what version we're talking about, and adding ensured another protection layer. Then the restoration option, I've already covered this. And whenever there's cleaning done, to do an automatic backup, because perhaps the backup or the cleaning is too aggressive and damages the website. We can give the user to do a backup. I can do a backup and then manually work on the tools and do things that the tool alone cannot do, then restore the site. And they also suggested that the app could be uploaded to Pipey, do a doc image, and that's something that I did. This malware scanner searches, cleans automatically some malware. I've focused on WordPress, and I've also added support for some content administrators. I've used clean installations and I've compared them with previous versions. I work with the OWASP malware signature, and this is easily extendable because I've organized it in such a way that it's easy to add support for different content administrators. It also cleans the malware and does backups. The user can do this. Everything is duly registered in logs. I've done some cleaning of the website as I do the cleaning of the file, and I've included the option of monitoring the website so that if there are any changes in the website, that is duly registered in a log. And now I'd like to show you a demo of this tool. There you can see the command line I've prepared. I've prepared a series of websites. Here they are. This is a custom site that doesn't belong to any known, well-known content administrator. I also have a group site and a WordPress, and I've reduced the size because it was originally very big, and since it has several megas, it would take too much time. And I've introduced deliberately some malware files that I detected with OWASP. And now let's test and run the scanner to see how it works. First thing that I'm going to do, for the sake of time, is to run a full cleaning of WordPress file. I've used the command to clean the website. Now I'll scan it and I'll also do a backup, as you will see. First thing it does is to upload the signature scenario. I do this with the OS project.
Perdona, se me ha olvidado activar la... Vale.
Tómate tu tiempo, Santi. Vale, sí.
Ahora ya tengo internet ahora, sí.
I have internet now. I had forgotten to connect the Wi-Fi. So, we're going to be generous. He was the first to take the floor, but please make sure that you have everything 100% ready, okay? We're going to give you 2 extra minutes, okay? Thanks for that. As for connection, of course, the scanner downloads a copy of the new website depending on the type of administrator and the version, searches for malware, and detects potentially malicious files that do not coincide with a clean version. So there's searching for malware, suspicious files. They are matched and compared and cleaned, and we also anonymize the site. A log file is generated that I'll show you now, which reflects all the info of eliminated files, and the backup will be generated as well as additional info on the cleaning process. Well, there you can see the backup of the website I've selected.
Este sería el fichero log que queda.
This is the log file. This is the outcome, so to say. There we have the suspicious or malware infected files, the authorizations. I'd also like to show you the monitoring option that I implemented yesterday so that you can see how we can scan and monitor a website so that all changes in the website are instantly reported. So there we have the monitoring process. The details or data of the monitoring process are registered in the log and appear on screen. I'll show you this now. If, for example, a file is created, and this is reported, notified, and it's registered in a log with the date and hour so that I know when that has happened. I will know whether it's malware or whether it's problematic. That is duly reflected in the log. And since my time's out, well, that's the end of my presentation. I'm sorry about those connectivity issues, and if you have any questions, please feel free to ask them. No questions? No?
Ir el siguiente equipo que sabéis que vais en lista.
If you know you're the team that will take the floor after the next speaker, please get ready. Santi has broken the ice. Congratulations, Santi. And it's true that it's always hard to be the first and to face unforeseen events. Those that take the floor afterwards learn from these mistakes. So please make sure you're ready. You've got everything perfectly prepared. And Santi is on his own. If you're several members of the team, please make sure that the task roles are duly distributed. Have everything ready, please. And now let's move on to the next presentation by Alejandro.
Sí, con 5 minutos, vale, eso, un segundito que voy a comentar. Vale, tenéis para referencia, para que quede.
For your reference, for the sake of clarity, we have a timer. You have 10 minutes, and we will draw your attention when you have 5 minutes remaining. Ahí, so that you know how much more time you've got left. Good morning, everybody. My name is Alejandro, and I'm here to present my project. I'm going to show you a demo directly. And at the end of the demo, I'll show you a file with the speed test, because that was the #1 problem I had with this software. If reboot the system with no parameter. As you can see, there you have the wizard, the support window, and the document line is that which is most important, the different options you've got to make a request to the software. With this program, in this demo, we're going to generate a hash of an existing file that is called 64K. There you can see it. And you'll understand now the speed it can reach. We introduce the document line. We introduce a parameter for it to store the file inside the hash in this demo. And then we execute it, we run it. This takes around 10 seconds. Yesterday, I discovered that the Windows version is a bit faster than the Linux version, which was somehow surprising. This is the hash that is generated, that is stored in a file. Okay, I'll interrupt this here because this flow of data can take some time, and the hash has been stored in this file. One sole text line, 64,000 characters. To check and verify the hash, what we do is view the command line, and then we select the compare function. If you have time, you can treat your adapter to a coffee. That was the joke.
Como podéis observar, pues el hash.
As you can see, the hash has stored the data, the date, the hour, the name of the file. It tells us that we have a file stored and the checksum of the file. This means that the original file can now be changed of name directly from the hash because it's installed inside. We can therefore extract the stored hash.
Aquí tenemos los dos archivos.
Here we have the two files. This is the one generated from the hash, the one that's stored. So here you have the comparison between the two files.
La comparación es correcta y bueno, pues
There you can see everything's correct. And now to complete this, I have to say that I didn't have time to prepare a presentation. But here you have a comparison of the speed tests that I've carried out over the night. These tests will be improved when I'm able to develop a more efficient compiler, because when the character chains are very long, I'm afraid this software is not as efficient. That's it on my side. Thanks very much and good luck, everybody.
Sí, hola,
Alejandro, just a question. This allows you to have hashes from messages from a text chain as from a file. Yes, I didn't say it in the demo, but it does allow a chain of messages and a file. Have you differentiate the settings to specify? No, it is in automatic mode. What happened a few days ago is that the program takes the file name by default, and this is not a failure but a feature, is the file's name by default to open up the file. Any other question? Thank you so much for your attention.
Sí, es lo que voy a hacer. Sí, nosotros habíamos hecho una librería.
We have created a library that was planned to implement different functions based on the Shasha algorithm. We've also thought about implementing AIS. It was quite complex, so it was just a project. Here you have the files, IIS files, where the majority of the functions work correctly, but the problem is to communicate them. The idea was an implementation that could allow pseudo-random number creation, starting with a seed that requires some security, so that any other random number generators, they also require a seed with a minimum level of entropy. But
La ventaja
the advantage of our implementation compared to DAS, DEP, DAS, random, or use a transmitter in an electronic system receiving electromagnetic fluctuations from the atmosphere, the advantage of our system is that it's faster and it provides the same degree of security. The objective, and this has already been implemented, an encryption algorithm This is the numbers generator. As I show in the first presentation, we just need to set a seed through this argument. In the context, this is a RAM context, and it's a structure that contains the possibility to introduce a seed, 32 bytes, and the nouns of 12 bytes. So we can get a seed of 44 bytes, which is very different from the 32 bytes seed used by random and ls random. The encryption algorithm, here we have the encryption algorithm, and here the encryption one. We just introduce the password, the noun, the length of the message, and a pointer signaling where the encrypted message is going to be introduced. This encrypted message will have the same length as the message in blank text, but we have also implemented a parser as an API. This is a client-server scheme that allows the customer to connect to the server and through a secure connection to execute different commands. This is the demo where we implemented what the jury requested to compile the server. In order to compile the server, we can select to compile all .c files of the project, and through a macro with the argument -d to define the macro, we create the macro server and it generates the server. We compile them and we get the server. It's an execute that is not too heavy. 23 kilobytes is not too heavy, and it allows information about the port. And the client is the same, the compiling process, the same as with the server, but the macro to be defined is macro client. We compile them, and when you execute it, you should indicate the host. It allows DNS and the port. Through a third argument, you can indicate a file to host the keys, as it was requested by the jury. We can do it with the server, but we don't have time to show how it works. And here we have a demo, and we see that they are connected. We can see in detail, this is the free way of handshake based on DCP handshake in the communication protocol of our library. We include two headers. I'm going to open this in a new window so that everything is clearer. Two headers bytes, which is the header XD, and then is sent to nouns. In order to avoid a walkie-talkie effect, if both ends communicate simultaneously, the communication is interrupted. We use different keys so that each of the ends use different keys. There's flow of different keys generated so that they don't share them. And if two messages are sent simultaneously, they can process it without using the same key or password for the message. The server parser that is implemented here, there is parser. The parser function is very simple. You just have to compare the received text, M in this case, with a chain, and you execute the necessary commands as they are indicated here. This function send MSG or receive MSJ, send and receive message, allow the communication through the created tunnel. When we receive SD command, it sends to the tunnel, or if we get WS is RTI, and if the command does not coincide, we send non-received command. So we get FGH. And the server also shows a log that can redirect a file, and the same with the three potential or possible commands. We can see in the WordSac that any of the requests in plain text, it'll be great to be able to speak about the whole protocol, but there is not enough time. It's a rather complex protocol. But I'm running out of time, so this is the end of my presentation. Thank you very much.
Una preguntilla.
I have a question. The bidirectional part, have you implemented it? Yes. Now, in the code, there is a different background or context for keys generation. Server and client have different passwords generation. Relax and breathe. This is not a test. I just like to see it. If you can show the handshake part, whether it goes in one direction or the other. The server works as any other server. The main gets the settings about the port. The rest is optional. The file where the key will be read, and the port says listen. If the user has opened up a connection or the client disconnect, the process also disconnects, and then we have the while loop. If we get a connection, we do a fork that will execute the function process request. So it allows different client connections. Here you have the function process request. We set the context for the creation of random numbers in handshake. We do it to generate nouns. If we have a specified file, we open up this one, and instead of using the prefixed one in compilation, in the macros defined in the file as .h, we were in server, and then we call the handshake function that is defined in the file as .c. This handshake function or just make an exchange of nouns, and to check each message we do a mac hmac, because cha-cha is a hash in itself, and cha-cha 3 was a hash function. but we didn't have time. We haven't slept all night because we were struggling with AIS. And when everything is set, to check that the keys are correct, there's a challenge where if you scroll down, you have the function here of the client handshake. This is the one that the client executes to execute the handshake with the server. So the client generates a nouns and sends it first to the header, then sends different bytes that mention the beginning of the session with our protocol, and then the nouns is sent. This nouns is used to encrypt messages. Messages will be encrypted using S nouns to break determinism, and the server will generate its keys. It will get the nouns used by the client and is going to use it to generate the nouns. The seed is different, so the same passwords or keys will not be generated through those functions. And then we check that the password is correct. Thank you. Thank you.
Vamos a sentar, que se quede Juan de pie, ¿no?
Ah, bueno, que vamos ahí. Usa los dos, ¿no? Para que solo suene uno, claro. ¿Este micro funciona? Sí. Duplica pantalla. Sí, funciona. Sí.
Pero como en modo presentador. Pero después vas a comentar que hacer una demo solamente.
No, ya está. Solo para
Si no hay problema.
Pero en plan, y ahora vas a
Os abro este.
Sí, hablamos de usted.
Estamos solos. Cuando lo digáis.
I'm ready. Okay, we are the members of the project Harvey Unchained. You know us already, and I'm going to introduce the contents. There will be the first item, the starting point of the project. As we explained the first day, we will speak about the milestones that we try to achieve during the context, the final project, based on all suggestions, the problems, and future improvements. The starting point of the project, as we said, the first day was that we had Twitter. We had a first monitoring of Twitter profile using the official API, and we had a great deal of information that was then realized in a file. The idea was to implement it in our platform. Álvaro will introduce what is the final project. Once we introduced Twitter, the rest of the social media. As Juan said, we started with Twitter, and we wanted to add at least Instagram, a little bit of Facebook, and also internet. The milestones during the context, this is what we've been working on the last few days. In Instagram, we got the basic profile information and the latest pictures published and the main data about comments and likes. Then we could get a location. We wanted to get location about each picture, but we didn't have time. About Facebook, we extracted friends from a profile, the latest posts, information from the wall, everything that is mentioned, and then basic profile information, where do they work, live. About Twitter, monitor all information from our target, extract all publication, banners, images. And about Pastevini, we automatize search using search, and we've also used API from Pastevin to get data. All of this is being integrated in a dashboard to enhance the analyst, the viewing of the information in a simple and clear way. Even though they may not have a clear technical knowledge, they might understand it. And now we will speak about each of the social media. As you can see, the project has been modular. We have been developing different parts. I was responsible for Twitter. This is all the information from the profiles. What we thought it was most important is general information that allow us to view it in a nice way in the platform. Once this was structured, we just inserted it in a database and then to the platform. Visually speaking, I will show a video about the platform, but this is just a screenshot of Twitter. And those are the registries, latest tweets, the activity, and whether if I'm tweeting from different locations, this is also seen here. Now, my colleague Alvaro will introduce the part related to Instagram. In Instagram and Twitter, the number of information is the number of followers, those that are followed, and the latest images, comments and likes of each photograph, and we could expand it to specific comments of each picture, location, etc. And now we're going to move to Facebook. We're running out of time. In Facebook, basic information, user information, the latest posts in the wall, and all the friends. This is a small demo of the script that executes in order to get all the friends. We use this system to automatize the task and recognize an image so that it works in any laptop device depending on the pixel, and we can substitute the manual work to the analyst. So the script does everything. Because this is the mobile version, is to include all the friends from a user, and once it's finished, this part is executed. It gets information about all the friends in the URL, and the information is into a file that can be uploaded to the dashboard. We have 3 ways of functioning: biography, posts, and friends. This is information about the latest posts from the target, and now information about the biography. We have implemented 3 methods so far, but this is scalable. From Facebook through scrapping, we can use and get all information we need. And it's been totally random. This person is not my former girlfriend. And this is the file with information from all friends that then goes through Python to the database. I will speak about the paste bin. As my colleague said, we've been using is a searcher that searches in Google and open source and paste bin, we might have the keywords of the target that we will introduce to the database related to each user, and that depends on our interest. Once the analysis is carried out, we show the results of the admin. Here we have found 313 posts. Then we'll have the links to Pastebin and the URL in Google. Here, this is an example of the script. We start with 2 keywords, admin and hacker. We will get all the paste bins, the new URL for each keyword. Once we do this, there will be a slide. After searching for all keywords, then we dynamically introduce new 2 keywords and we start the process again. This is an automatic process that is running in the server, and as we introduce new keywords in the database, they are automatically analyzed. And now, not to do just a demo, we have prepared a video of the dashboard. This is the index with our objectives, the keywords, users, then a form for the new target. It will be user data and the social media we're going to monitor, as we see in the example, Twitter, Facebook, Instagram, and is scalable to any platform. Then we have the current targets that are already in and actions to view more about the profile. Here we could get in each specific profile the information we have. In Facebook is a small Facebook biography, latest posts, and my friends section. Now Twitter description, picture, the banner, followers, follow tweets, latest tweets, recent activity, and a small timeline that, although it's not implemented yet, that's the way it would look like. The same about the Instagram. We have added a button to launch the scripts in an automatic mode. In Twitter, the number of tweets, whether we want to monitor it on an ongoing basis or are still pending to be implemented, but it would just be a matter of launching the script from PHP and then to add keywords as CyberCamp, and we can see the results. I know that we are behind the 10 minutes, but the APIs didn't bring enough information. Tools integration was more complex than we thought, especially Facebook. We just had 2 days, so it was not time enough to implement everything, and the solutions proposed by our peers took some time, and we had to implement it. As future improvements is to integrate the platform in OVA local. This is one of the recommendations by the jury, and we think that is rather interesting to integrate new platforms, as you can see on the screen, to improve Facebook data extraction and updating and eliminating information in a dynamic manner. Thank you very much. Sorry for going a little bit beyond the time. If you have any questions, now Danny is going to ask something. Just to look, to ask for something related to the code, but we don't have to do it now. You can talk to Danny.
HDMI.
Sí. HDMI.
Si va a hacer eso, duplica pantalla, ¿vale? No vayas a extender. O si vas a hacer, vas a trabajar.
No.
Algo pone, ¿vale?
Déjame el pinganillo este, el logo. Hola, buenas a todos. Somos el equipo.
Hello, good morning. We're here to talk to you about the results of the Droid Sentinel application. What's the main goal of our tool? To design a tool that's able to determine whether our device is being part of a distributed denial of service attack. We want to introduce pattern recognizing and machine learning, also identify denial of service attacks that are more and more common, and we want to promote the cooperation of the community. We want to create a core that can be able to detect whether a device is being part of a denial of service attack. We've selected Android and a mobile phone, but we can do it with virtually everything. What were the challenges? What did we know when we began? Monitoring techniques, decision-making and prevention, self-organization of networks, and taxonomies of denial of service and their relationship with botnets. What problems did we encounter during the development of this app? Outgoing traffic analysis. We come in from a model in which we're at the center of a network and we analyze all the traffic. But in this case, we're only analyzing the outgoing traffic of a device. And this is very homogeneous because we use the same 10 or 15 apps that have very similar and constant traffic. Second, analysis of non-stationary data. What is this about? The data from the data center, as we worked in the past, are stationary, are more or less recognizable, have a series of patterns, but not in this case. Maybe you have your mobile phone in rest mode, or you download an app and you play streaming. There are many peaks, and it's very hard to identify patterns. And then granularity. What does this refer to? Our series are sometimes not too big, or our algorithms rather require very long series. That's what makes predictions more accurate. Since this is a hackathon and we had a time restraint, we had to go for a more restricted time series. How did we face these challenges and develop the app? First, analysis of outgoing traffic, both legitimate and malicious. Second, unexpected behavior. Third, study of aleatority or randomness through entropy. And fourth, calibration. And fifth, measurement. And points 3, 4, and 5 is where we find more innovation in our projects, i.e. the core of our project, that part where most of the research lies. In the first part, we need to determine whether it's malicious or legitimate traffic. Based on literature, we've finally gone for this approach to determine whether the packages are legitimate or malicious. Second, detection of unexpected behavior. To do so, we based ourselves on 3 pieces of info on packages: the number of flows, the average and maximum number of packages, and third, the size of packages. We don't work directly on this. We use a metric, entropy. Entropy measures the level of dispersion of data, the probability or likeliness of dispersion of data. We've used to this end Regi's entropy, but as we used it, we understood that there are different options, and we finally end Exanon's entropy, and we thought that this was the best option, calibration. Why calibration of algorithms? Why using a generic algorithm. We're talking about non-stationary data. There are no patterns or very few patterns between the observations. This forces us to calibrate and reset them each time differently and to adapt ourselves to the time series. That's why we use a genetic algorithm that simulates the evolution of the species, i.e. natural selection. What it does, it assembles genes and creates a population, the end population, which would be the optimum population. Each chromosome represents a possible configuration of an algorithm. So we're looking for the optimal configuration or setting for the algorithm. And to this end, we use Smarter, which is a measure that helps us know which of the chromosomes are better. And then algorithms. We've had a lot of work to do. We didn't want to limit ourselves to one sole algorithm. We worked with 5 different algorithms, and we used genetic algorithms for each, calibrated them, tested them. The time series vary a great deal. So we wanted to choose the algorithm that best responded to the time series, and we went for the triple smooth exponential algorithm. And the decision criterion. How do we know whether there have been anomalies or not? Well, through adaptive thresholds. What are adaptive thresholds? These are margins where we expect the prediction to be to the right, and it's a bit hard to see. We have an explanation. The time series is the blue line, and the red and green line represent the adaptive thresholds, upper and low. And we see that generally we're within thresholds, but at a particular moment in time, we go beyond their thresholds. And it is here where our tool comes into play. It says there is anomalous traffic, there's something there. And we are reported about a potential DOS. Let's move on to the demo. To this end, we've developed our app. We've used an Android emulator. It's running already for the sake of time. First thing is take observations or make observation needs to feed itself. So it's going to take 20 observations to be able to start to predict. This parameter, as many others, can be customized. Here we've introduced only 4 because it didn't make much sense to introduce more. And for an average user, if we introduce 20 or 30, because that's possible, it would be perhaps too overwhelming. So this is the interface, and the idea is to implement advanced options for advanced users so that instead of maybe 4, you can have 20. And this would help users and developers move on and know what they need to focus on. So what are we going to see with this demo? Well, to the left you have just a log so that you see that it's executing the app. And now it's going to start to predict. We're going to start to see prediction values. They're already all in 3 and 1. Normalized entropy, as you will see. And we're going to see how it generates predictions. And what we're going to do is use Lloyd, which is a tool that you probably know, in order to generate a DOS attack, okay? We're not going to crash any website. And we're going to see, it takes some time because it's making observation, but soon we'll see how our report is going to be issued to tell us that we may be subject to distributed DOS. So here we have 24. This is the value of 24, and now we're going to activate our tool. We're going to introduce whatever website, and we're going to see how this works. Good. Now we're going to launch the attack. It's starting. It's not dangerous. We're not going to crash the website, but the idea is to see how we have the report instantly notified. And we've just been warned that there has been an anomalous change in the time series, and therefore it's possible that we're being part of a DOS attack. Last, regarding conclusions and future work. Conclusions, core functionalities. We're able to have a core that detects DOS attacks via predictions using genetic algorithms and entropy. Second, a test scenario, as we have seen, and validation of the proposal. We were able to do or satisfy our objectives. Future work, optimization of code to make it more efficient. Scalability, as we were saying, this has been done for mobile phones, but our ideas that can be used for whatever IoT device, computers, etc. Updating of SDK, you mentioned this as an issue. Updating that would take us some time. We decided to leave this for the future. And the MF report, we talked about the possibility of issuing a report that could be sent so that the community could have access to that. And we set a standard IDMF. We implemented it. It's still not uploaded, and that's work for the future. Thank you.
Bueno, lo primero, felicitar.
I'd like to congratulate you for the work you've done. The research has been wonderful. You've explained this very well. Just a technical question. When you detect a threshold, you enter that value to feed in the algorithm so that it can learn from that, and maybe it masks a real attack. Yes, that's correct. When we see that there's a peak value, when the time series advances, that value is going to be detected, and our algorithm is going to reuse it for the next prediction. So yes. As for the threshold is adaptive. So with each new iteration, it is modified. With each new observation, the thresholds are adapted.
Pincha. Si va, duplica 900. O si tienes que hacer alguna vez para poder verlo ahí.
Buenos días, somos MUPAD.
Good morning. We are Mupadex crew, and we're here to explain to you our experience with our tool, Trail, and let's remind you what this is about. It's a very simple architecture sensor customer. The sensor will be in a traffic concentration point. We'll send it to the server, and the server will be a website where you can see all this. We've wanted to add a new sensor, a process sensor that is executed in each host so that we can correlate the malicious sensor detected by the traffic sensor and the process sensor. So what Trail detects, and also a small button that says kill, and that kills it. A problem we had here was the secure communication between the host and the server, because we're talking about a package that can kill whatever process. So you need to secure this. And we've talked with the Just Chacha team, and we thought about implementing their solution. They checked Python, which is what we work with, and we checked their functionalities. And in the end, we didn't implement it because we would have to call our Python code from their PC. What we saw was that they could get a package and re-inject it as many times as possible. And we could kill a PIB as many times as possible, and that is dangerous. So unfortunately, in the end, we had to use SSL, the classical architecture. There's an authentication by the customer and by the server with certificates. The main problem to detect the PIDs related to packages. This seems simple, but it turned out being very complicated. What's most difficult is that you need to treat with very low level, i.e., in the case of Linux, the kernel, in the case of Linux, we have the audit framework that has some rules for each call to the system. So we introduce a rule for socket.connect, and we have our PID. We log it all. In Windows, it's more complicated. Net event session. Nobody understands what this is about. It's something that has to do with a PowerShell. You were laughing the other day, but it's really complicated. It's really tough. It's just as PowerShell. And as audit framework, it's a bit messier. In Mac, there's something funny. They introduce the data we need regarding the packages, and this isn't released to the internet, but that's basically it. And we can read it from there, and we see the same behavior. And last, a general one, Python. So you can plug in Python and use these plugin. And if you ask us who sent this, we can check our table. And if the socket is open, we can say this. If the socket is closed, we won't be able to know that. And that's it on my side. Now we will show you the demo. My colleague Carlos will be in charge of explaining the demo to you. Let's move on to the demo. First thing I'm going to do is explain to you what we're going to do in this demo so that you don't get lost. We're going to test 3 different architecture, and we're going to capture 3 types of packages, the 3 main protocols, UDP, TCP, well, there you can see the 3. And these 3 types of protocols, all of the packages can be detected in the process sensor of Linux and Mac and Windows. However, for sake of time, we're going to capture an ICMP in Mac, UDP in Linux, and TCP in Windows, okay? We're going to use 3 different architectures. Within Mac, we will be executing both the server and the sensor and the process sensor from Mac. Within the Mac machine, we will have a virtual Linux machine whose packages will always go through the Mac interfaces, and we'll use the sensor we are executing in Mac, and we will be able to view the packages in the Mac server. And third, we're going to test a third architecture. We will have a Windows machine in the same local network, but not being executed within Mac, but executing its own sensor. This means that this Windows device will establish a TCP connection with a malicious IP. The sensor will detect this malicious connection, will send a log to the server. The server will talk with the process sensor of Windows and will send it the PID of the process of this package. Now let's take a look at the real demo. As I said, let's begin with Mac. We're executing the server, the process sensor, and the mall trail sensor that detects malicious packages. So inside the Mac, we're going to send a pin to a malicious IP, check whether it's being executed, and kill the process from the mall trade console. Here we have the mall trail console with previous traces so that we can see how everything is being done. But now we're going to create a new process. Let me highlight that we've added 3 columns in this console: process ID, process process name and kill process, the goal of which is to kill the process, see the name of the process, the name of the malicious package, and the PID. This seems dumb, but if you read the code of Montreal creator, it was interesting to know how he did all this in order to develop this. And this allowed us to order the packages based on the PID or the process. So we send a PIN number with the Mac machine. We send the PIN to the lower right console. It's being sent well. It's received. We're going to update the Montreal console. And we're going to see the PIN. If we take a look at the console, when we press kill, we're going to kill the process. It has died well, and as you can see here. Now let's move on to Linux, to the demo in Linux. Was more entertaining. We have the process sensor running, and we will going to do a routing to a malicious site. So when I press the button, I will have to look for the process and kill it before it finishes. So let's see how this goes. We take a look. We have killed the process well, and now we can read they're killed. It's being killed before the trace route is finished. We're good on time. Now let's move on to the Windows demo, in which you'll be able to see that we will run Chrome, issue a request to a malicious site. We're going to find that request within the Montreal console, and we're going to see live how the Chrome process that is being executed in the computer of this, in the screen of this computer, is killed from the Montreal console. There's no connectivity with the malicious web because the malicious web does marketing. And as you can see, we can kill it perfectly well. Let's reboot. Here it is. Wonderful. We're going to press kill, but take a look at this screen so that you see how the Chrome process is killed. As you can see, we have also managed this error. Let's see if we're able to find the correct process. We're doing this via mobile. Let's see if we're able to find it and kill it.
Vale, le hemos enviado la petición a...
The request has been sent to the process sensor of Windows, but we're going to restart the Windows process sensor. I said that Windows was a bit messier, and using Python's PowerShell isn't easy either. Do we have it ready? We've sent the request. We're waiting to receive the process. We're logging everything. Here it is. We refresh Malware's web. Here. So we press kill and we close it correctly. We complete the process. We've exceeded our time. Sorry for that, and thank you, everybody. I have a question. During how long have you trained the trace route and moved your finger to press kill? A couple of times. Yeah, it's been quite a race to set up the demo, use the mobile as the point of access. Setting the structure took us a significant part of last night, so you can imagine. Well, the idea is that it can be automatically implemented with severity rules. If the process is killed automatically, well, this demo, of course, wouldn't make any sense. this can be implemented as a future enhancement. In the future, the automatic killing of processes, we didn't have time to do this, and to have don't have the kill button activated if the process has already been killed. Thank you.
Bueno, la demo del Windows de los huevos, tío.
¿HDMI o VGA? ¿Tiene salida HDMI?
Sí, pero tú estás con la funcional.
De alguno.
Siéntate. Coge. No, no. Gracias.
Hola,
Hello, good morning. My name is Javier. I'm part of the Cyber Watcher team, and first of all, I'd like to explain to you the development of our idea from the beginning of the hackathon till now, because we consider the comments made by the jury and we've changed course somehow. Initially, we wanted to search OSING by entering the full name of a person and the city where that person lives, and our tool showed the internet links where the info on that person was located and whether we had found sensitive info, for example, academic background, employment background, and we wanted to add further criteria. This night we've included yet another search criterion. Also, search regarding the user address. It's true that we've identified or faced a series of problems, specifically with the ID, as my colleague will explain, also problems regarding the execution times for the matching of data, because we don't only obtain data once we have that data, we run analysis algorithms on them to try to obtain info from those data sources, more filtered info or screened info, and that has posed problems. But in terms of scalability, should we have time, we would be able to fine-tune the algorithms and obtain further data, add more search criteria. One of our ideas for the future is to introduce a function whereby the data collected are then implemented in a PDF. Didn't have time to do this. Another idea that we have in mind is that when we do a research, it can be stored in the database. Our database only stores one search, but the idea is to have a historical log of the search. That's an idea for the future as well. And now I'll give the floor to my colleague. With CyberWatcher, what we wanted initially, as my colleague said, we wanted to conduct a search and that whatever person could do this, anybody. The problem was that we couldn't ensure the security of only looking for the data on that person in particular. And not everybody, the jury gave us some advice to have security-backed, certificate-backed security, and we decided to use the electronic ID with a USB drive. Problems, we had to carry out two processes. The Spanish national, the Mint, issues the ID, works with the law enforcement agencies, and we thought, okay, what if I find a place where this process can be done by myself? And that's when we were able to find this company. Traces, it's hard to see. Practice is a company that does validation with the Spanish Mint and with the local police. And this company works with all the certificates that you can see from Spain and other countries as well. And we can see how with Spain there's a specific section that works with the local police. Okay, we're aware of this. So, now I'd like to show you a demo with my ID document. First, they asked me for an authorization because it's going to use my data. I say yes, access, and then it downloads an applet that will be installed in my computer, which is this one that you can see here. I need to, of course, accept. I open the link. Now it's going to ask me for the password. I'm going to try to combine both screens. So I'm being asked to introduce the password for the certificate. I'll introduce my ID number, but there was a problem with the police. So the IDs with specific support number had been attacked and deactivated. I didn't have time to go to the police to renew the certificate. So the app is going to tell me that I won't be able to access. Here you can see that I cannot access. How can we do a demo? Well,
Bueno, lo que me ha comentado mi compañero.
What my colleague said, the idea was a searcher that anybody could use, and through the certificate, user could only find data related to the public part of his or her digital footprint without giving this possibility to anyone else. So we keep security measures that respect everyone's privacy. Here it was a previous search, and here we emulate that the full name could be collected from the ID. Now we see the login screen and everything I presented about the certificate. Here we have the code about the certificate implementation in GitHub. Here working with an API related to my Strato server, and then we do the emulation where the full name would come from the ID, and the user will only have to type the city from a list or the item extracts, which are the rest of the potential searches as sites, venues. This is going to be now the simulation. I'm going to type my colleague's name, Javier Manrique Callejero. It's not seen on the screen now. Javier Manrique Callejero. Now the city is Zaragoza, and he's at present at a gym. I said find, and the analysis would start the data collection until the final results. When you introduce the name of the person, the city, and the criterion, there is a search with those criteria. We get internet data, and then we filter whether the data are really there. Then we applied an analysis algorithm to find possible locations in the text. We have a database with cities of the world, if in this register with the website text we find any of the cities that is in our cities list, then maybe some of the cities on the database are not real cities. So we have another algorithm for a second check-in that browses the internet to see whether this city is a real location. We also have a data analysis algorithm to extract email related to internet browsing, and the SQL query. We can see if any of the words present in our dictionary are inside the registry. We have, as I said, a table. It's a dictionary. It has a field. The name is field, and then we add a value. We have the field, whether it's a school, course, activity, subject, mathematics, and if it inside this dictionary, we introduce it in possible studies. In addition to this, we show a risk percentage. Once the Fair Watcher is completed, that estimates the relation of sensitive internet information based on the total data received. Here you can see in the map possible locations of this joint search, and we see the links where the information is present, and we see whether we have found emails or not. And in the lower part, we show the level of risk based on sensitive information. We didn't have time to add a graph to make it more visual, but we have the value. This is not finished yet. We didn't have enough time, but if we had more time and we will go on improving it, then we will make it more pro. This is just to show some data. I will benefit from those 8 seconds to thank the jury and the organizers of this event. Thank you very much.
Adelante. Muy bien. Nos quedan...
Okay, we have 2 more teams. We are on schedule. The idea is to get ready before the presentation. So we still have 2 teams to go. We are okay with time, and take into account, please take into account your own votes, because you are focused on your own presentation, and then you forgot about the other teams' names, etc. But don't you worry, in the other location where we will continue working, you might have a chance.
¿VGA o HDMI?
VGA,
Bueno, tienes HDMI.
pero no tira, no sé por qué. Si quieres probarlo, pero no funciona.
Ahí lo tenéis. Duplicarlo, ¿vale? Te lo duplico. ¿Qué es Windows o no? Eso no es Windows.
Voy a coger eso. Hola. Sí, sí.
Hello. I will speak not from the stage, because I feel more comfy here. This is the drone. Please do not shoot it down because I love it. Our project is TOTH, Transport Oriented to Hive. As you know, here we had to give our best. We are here to compete. We haven't slept much. We just had tons of coffee, and that's the same for the rest. It's a killer for all of us. In total, it was 2,880 minutes to complete the project. We have created more than 1 million of code lines from scratch, and we have completed 95%. We haven't been able to attain 100% of the pre-plan project. How did we start it? We came here from zero. We didn't have anything, not even a line of code. We only had the idea and the draft. As I said, this was our starting point. We wanted to come here and start the project here. And to make such a complex project, it was quite a task. It's been difficult, but we are quite satisfied. What we have created, those that have created TOTH have been using different tools. One of them is kgen.sh that generates public and private keys and is in charge of encryption. Then create as.sh generates an access point for our clients. So the drone will provide an access point. Connection.sh makes the connection with the closest spot. Caminos.sh is a script that simulates the use of a distance vector that follows algorithm Bellman-Ford used in our AP. We also have the tools inside the server. There are different. We've been trying different connections and different orders, and we will do a demo with one of them so that you see what we've been trying, all the application attempts and recommendations by the jury are also there. Remember that we started from scratch. All those tools and some more that I might forget have been done from scratch in only 2 days. What do we have? This is our drone. And remember that we have Elena and Jose. Elena wants to connect with Jose. Elena, here she is. She connects to the drone to send the message. We'll send the message to the drone, and the drone will send the message to Jose. This is what we have so far. And you may say or think, what about the rest of the drones? We need more drones. Yes, the idea of this project was to launch around 10 drones so that they could communicate among themselves. Because we only had 2 days, we haven't been able to do it. We have planned it so that we can continue later on with the project and develop it with more drones. But this demo only works now with 2 drones, I imagine. And then we had to reinvent the wheel. Since we started working in Hackathon, we've been given help about network protocols. We've been following all advice, and we've tried as much as possible. Then we realized something. What we said at the beginning, our idea is to bring the future into the present. For that, we shouldn't use old technologies but adapt them to our project. The problems we encountered were because we should have our fixed nodes, because we're going to use drones. Oral nodes will be moving. We have to adapt old technology, and implement the protocol from zero was too complex. That's why we hadn't implemented communication among the 10 drones. What will the future be like for TOTH? This was just the starting point. This project is going to be the end project at university. We want to continue with just pressing enter so that the drones take off and communicate among themselves. This is a communication system with nodes that are difficult to shoot down. It's not just to have different nodes. Our idea is that you can have a secure communication. You launch the drone. If somebody throws a stone, can shoot it down, but nobody can physically take it. This is another difficulty, and thank you. Especially, I'd like to thank the members of the jury for their ideas. We've tried to implement them all. Thank you to the Hackathon and the organizers for creating this event, and thanks to our colleagues for all the support and encouragement throughout the Hackathon. And now this is the demo of what we have, or our progress so far.
Que, por cierto, si el jurado puede coger esto.
If the jury can now use these two computers, we're going to leave one to each member of the jury.
No, en este caso sería.
Now, the drone is the Acer one, that would be simulating the drone. So one computer would be Elena and the other one, Jose. Just pick up the one you like. You can be Elena or Jose, it's up to you.
Vale. Voy a aprovechar, se me...
I'm going to use this time so that you can see. We're going to show you the starting point, the script, and you will see the communication. What they would do before giving them their own computers is to go to the folder where our program is located. Here the ESTOTH, the name is Directo, and we will be in Directo. And in order to do the setting and provide content, we should use the file config.es that gives two options, start or help. They can be reused by anybody. We might execute start and we'll give information about the nodes, because we want to have as many drones as possible. It gives us the password for authentication so that messages can be sent. I believe I've created the folder when it was already there. I type information about the user, and I execute again one node, and everything is perfect. So we might have now the user folder with information to the user, only for him, so we avoid intrusions. Folder nodes, it will be the folder with this specific node. We might be in node 1 and we will create an access point. Because it's already been created, we don't need to do it now, but so that you can see the steps. The access point is created and to set the server so that they can connect. Those are all the test applications. Each connects in a different way. One sends everything in plain text, although some others are encrypted. Now this is going to be a chat between both computers, and we will view the conversation. It was already loaded. If you can see it, node related to the index to load our server. Once it's loaded, it says that is in port 3000. We will go to our local host 3000, and this is what they could be viewing. But now it's empty. But now, if Elena or Pepe can send a message so that we can check. Pepe is sending a message. And Elena's got it. Elena, can you reply?
Como veis, la comunicación...
As you can see, communication works live. He sends a message, the server receives it and sends it directed to all users connected. And this is our demo and the end of our time. Thank you very much for your attention.
Una preguntita.
Sí, si quieres.
¿Este se escucha?
Can you hear me? A quick question. The connection between Elena and Jose and port 3000 is not using HTTPS for a reason, is by sockets, directly by sockets. You send it, the server receives it, and then send it to the recipient. But we're using normal sockets? Yes. There were different demos. We have the exchange of tables. Each folder, if you want to test it, makes a connection in a different ways. There's a folder that sends the chain so that you can connect when you have 10 drones, and you can set the connection. We haven't been successful yet, but here it is, so we can develop it later. Thank you.
Gracias.
Tenéis el...
And the last, but not least, team.
Hola, hola.
Hello?
Sí, es su portátil de ahí.
No, espera, Ricardo, que tiene que darle algo ahí.
Ah, vale, vale.
Recordad que en cuanto a...
Remember that after this demo, we will go to the Hackathon area for your voting so that you can rest a little bit until 1.
Vale, ya estamos listos.
Okay, we're ready. Don't look at the man that is working behind the stage. This is quite complex for just one person. Okay, as we said in the presentation, our tool is a program to find wireless networks and devices, and we're going to show some real use cases. About development, as we said, we started from scratch. The project had a software part and a hardware one. In relation to the code, is not too long. As our colleague said, code lines are very expensive in time just to write a few lines. Therefore, software is divided in a core part that is independent, executing the different plugins. And there was much effort to do to find the right plugins. And it's been hell until we found them. And then the software also has a viewer through web service, and those web services can be used to view data. We created a small panel, and then the complementary part, that is the hardware hacking. We had to struggle with many different devices in our 3 heavy bags. Some we managed to make them work. We haven't been successful in other cases. Let us show different demos, and we're now going to move to demo number 1. Demos, we're going to start by the lowest level, or those that are not so nice, and then we will improve as we go along. Here the idea was to detect an attack with this gadget. It's a BTS GSM that emulates a real one. The plugin is implemented, is in the repository, but it's extremely slow, so in just 10 minutes we don't have time to show it live. Now we have implemented a tool that scans GSM networks, and the idea was to implement and control the power. You can see different channels with the frequency and power. The idea is to compare it with the sign broadcasted by this device that has to be higher. The problem is that this takes 15 to 20 minutes to go through the 900 to 1000 megahertz, and we don't have time for this now. If we now move to demo number 2, what we've done is scanning Bluetooth 4.0, low energy Bluetooth, as this bracelet with a small lock. If you now show the control panel, those are the devices. Because there is a great deal of noise, it's not so accurate, but otherwise it will detect more. What is the functionality of this plugin for people's control residents? If people wear the bracelet, we can see if there's a missing person, or we can limit areas where if there is an intrusion, an alarm might be activated. There is a device that the name is a Smart Lock, and is this one. is a Bluetooth lock with an application. If we remove the batteries, it will be switched off, and this goes on scanning, and now the smart lock should disappear from the panel. As you can see, it's just gone. So now we could activate an alert or whatever. Now demo number 3. Is similar to the Bluetooth one, but this is an inventory of Wi-Fi networks. We can have a white list that we want to monitor or ignore those that we do not want to monitor. We can see if there's a fault in the service. If any of the nodes no longer work, we can detect malicious network or networks that are being used to filter data. Here you can see all Wi-Fi networks that are around this device, CyberCamp and some others. And as with the rest of the screens, it provides some data, frequency, channel, and power, so we can have an idea of how far or how close they are. Now the next demo about the Wi-Fi with this gadget that we have here, the pineapple. Ricardo, can you show it? Yes. Is Pineapple Mar 5 is used for Wi-Fi network audits, and it also allows attacks. It has a program 30 attacks by default, although you can attack more. One of the attacks, Karma, captures the probes that the telephones launch to connect the Wi-Fi networks. Known Wi-Fi networks, and this device detects those probes and emulates the Wi-Fi to deceive you so that you connect to it. We have designed a plugin that detects this type of attack. As you can see, it's in green because right now it's not, the attack is not in progress, but this is the pineapple interface with all the potential attacks. And here you see the Karma one, that when you press the execute is on. No, the attack is not launched yet. The pineapple is somewhat problematic. You've seen the list with 40 or 50 Wi-Fi networks available. Now it's working.
Funciona, seguro. Vamos a pasar.
It works. I'm sure it does. Let's move on to the next demo. Basically, it would launch the attack that would be then detected, and so it would turn red. Let's move on to the next demo. You can execute RF map directly and hit PMR. So we're going to be super fast. What you're seeing here is a real scenario. Well, let's imagine a real industrial 4.0 environment with 8 pieces of equipment connected by monitoring sensors, and there are 8 links, okay? So, for example, I'm going to simulate that one of the links crashes. For example, number 6. I'm going to hit signal number 6 from here. Another demo effect, unfortunately. It's a demo effect. Oh my goodness. I'll explain it to you. I would be able to interact with each of the 8 channels. It would flash in red, and this would help us monitor that these 8 links to the 8 machines are working, and if one crashes, we will know that. Now it's working. Yeah, now it's working. Number 6. This could be used, for example, to analyze a spectrum and look for gaps, CDT or radar on number 6, and I change this to number 2. For example, now it detects number 2. And this, of course, has many applications to look for links that are crashing. And thanks very much. Sorry for the delay. I have a question regarding GSM. It's true that to do local mapping, it takes time. The GSM plugin, once it's been mapping for 20 minutes, does it identify new ones? No. We did the plugin of the core that collects all data. We don't have that covered. That's where we would program an alert to detect a new one with an X difference in power. But that's part of the front end, and we haven't done this because we didn't have time. The others were prepared, but we're aware of the difficulties. But the core is done. The core is done, yes, it draws a list, and you can see it in text format. But you obtain the list of all VTS and the power, associated power. Thank you.